Hi, how are you doing? My name is Albert Michelson. I'm one of the people who conducted the Michelson Morrison experiment in 1887, which seemed like a complete waste of time, but in the end, hard work always pays off. What we were trying to find was luminiferous ether. That's what we were trying to detect and discover. Let me tell you about it. We said that light had to be traveling because light traveled in waves which are similar to like sound waves and water waves, which travel through like water, walls, or air. So we said that light has to be traveling through a luminiferous ether, the light waves. So we tried to prove this and detect the movement of this luminiferous ether that surrounds us but is invisible. So we started working at Case Western Reserve University in Cleveland, Ohio. And before that, like a little background on what was going on at the time, about 10 years prior, less than 10 years prior, Thomas Edison was making discoveries on light and sound and like improving light and sound because he improved the telephone by coming up with like a telephone transmitter that improved like the way that sound waves traveled through the telephone, and that was around like 1877. And then he also helped invent the phonograph, which was able to actually record sound, which is pretty cool. He also began to develop the incandescent light bulb, and later, he ended up like developing a whole light system for a whole town, which is pretty cool as well. So that's like the question came about: how does light movement, you know, how does it move? That question came about, aroused, came across our minds. So I collaborated with my colleague Edward Morley, he was good at chemistry. He was a chemistry teacher at the Case Western University. So he was a pretty good person to work with. And but my role in the experiment was like I designed it. I came up with the idea that okay, this is what happens. You have a mirror, like you take two mirrors that are perpendicular to each other but not touching, and which is similar to like a box without the corner. You see. Then I place a glass in the middle that's like the same distance from this mirror and the same distance for that mirror, and it's like at a 45-degree angle. So that light can pass through and hit this glass and split in two. One half of the light is gonna go towards this mirror, and the other half is gonna go towards that mirror. And then it's gonna bounce back towards this glass that's at a 45-degree angle, and go down to a device that's gonna be able to recognize if these two beams of light, well, this one beam that's split into two, these two beams hit this device either at the same time or different times. So, and that will tell like if it hit the device at the same time, that indicates like the position of in the luminiferous ether, and like if it hit at different times, it indicates a shift in the luminiferous ether. But unfortunately, however, my experiment kind of failed. In a sense, it's failed. I put it failed because it always, like, the light beams always hit at the same time. I don't understand that, but they hit at the same time. Now I do. I understand it now though. But at the time I didn't. It was like, man, that I shifted it like just a little bit. Had the device sitting on Mercury, and just with just tiny little shifts, and it always hit at the same time. So fortunately, in the end, my experiment is like it kind of get brought about the question: is does luminiferous ether really exist? you know, like, so it kind of like improved the physics community. It really impacted the physics community. Let me tell you how. Because the experiment introduced the theory that light is not affected by this ether. It also fueled Einstein's special theory of relativity, which indicates that the speed of light is the same to all observers, no matter what speed they're traveling. So it made a real impact on the science community. So much of an impact that I ended up receiving a Nobel Prize Award in 1907, a couple years after Einstein's discovery of special relativity. My failed experiment made a major contribution to the scientific community. It became famous, and I was the first person to receive an award in physics for like in the Nobel Awards. So it was a major contribution because I discovered that light is the speed of light is always the same, and I didn't even know it. Thank you so much for your time. Have a good one.